All right. If you were looking for help for the Ohm's Law practice worksheet, you have come to the right place. So let me share this with you guys real quick and we'll get started. Where did I put it? How did I lose it already? I just didn't scroll enough. All right, so here's the Ohm's Law practice worksheet. We'll go through this. This will be the key for you guys if we need. So I'm going to write the equations up at the top real quick so we have them. V equals I times R, right? That's the voltage version of Ohm's law. R equals V divided by I, resistance version, and I equals V divided by R, current version. And we've got, I didn't really leave myself space to do it, but maybe I can fit in this corner. Voltage is V measured in volts. Current is I measured in amps. And resistance is R measured in ohms. And the only one that's weird is the ohms, right? It's an upside down horseshoe instead of like an O or something. That's the Greek letter omega. So ohms, omega, I guess. All right, so I'll just run through these really quick. We've seen stuff like this before, so it shouldn't be too crazy for you guys, but we're looking for the numbers to see what we've been given, and then looking for the question. So in this case, I'm going to use green. We can see 0.5 amps. Amps is current, right? Current's measured in amps. This is an A. When connected to a 120 volt circuit, volts is obviously voltage. So we've got 120 volts and 0.5 amps. Calculate the resistance. So there's our question. Question, or I guess order is more like, it's not really a question, but calculate the resistance. So we are looking to solve for resistance. That means we need Ohm's law equation that is solved for resistance, which is this guy right here. So R equals V divided by I, 120 divided by 0.5. And 120 divided by 0.5 is 240. And that's a resistance, which means it is ohms. And there you go. So we're doing really the same thing we did in the last Ohm's law practice. Maybe just a little bit less guided this time than it was in the last one. If we look at the next one, 12 ohms. Ohms is the measurement for resistance, so that's a resistance. 12 ohms in a 120 volt circuit. What is the amount of current? So we're looking for I. All right, so if we're looking for I, we want the equation that's solved for I. That's obviously this last one right here. I is equal to V divided by R. I is equal to 120 divided by 12. And 120 divided by 12, we get a current of 10. And current is measured in amps, so we throw a little A after that. There's our answer. 10 amps. All right, so maybe you guys need help with this still. If you do, I'm going to finish this up. You can follow along. If you're good, go ahead, do the rest of it. Maybe just check back at the end, check your answers, see how you did. But I will continue doing this if you need the help. So subwoofer needs a household voltage of 110. So there's a voltage. Push a current of 5.5 amps. So current, right? Amps is current. So there's a 5.5 right there. What is the resistance? And we should probably get the picture by now that if we're given we're given two things, we're going to have to find the third thing. So resistance is what we're looking for. That's the middle equation. So R equals V divided by I. 110 divided by 5.5. And I think we get a resistance of 20. 110 divided by 5.5 sounds like 20 to me. There's our resistance of 20. Continuing on, 12-volt car battery. Pushes charge through the headlight circuit, resistance of 10 ohms. So 12 volts and 10 ohms means it's probably going to ask us for current. How much current? There's our question right there. So we're looking for current this time. We're looking for I, which means we want this third one. I is equal to V divided by R. 12 divided by 10. And 12 divided by 10 is going to give us 1.2 amps. There's our current. Scroll on down here a little bit to get the next set of problems. Walkman uses a standard 1.5 volt battery. So there's a voltage. How much resistance? So I actually get the question first in this one. How much resistance, which means hopefully they give me a current, is in the circuit if it uses a current of 0.01 amps. It does give me a current, 0.01. And we're looking for resistance. Resistance is voltage divided by current. Right, we're using the same three equations over and over. So hopefully we're getting used to them a little bit. 1.5 divided by 0.01 and 1.5 divided by 0.01 is 150 ohms. My best guess. Next one, how much voltage would be necessary? Actually, we get the question right here. How much voltage? So we are looking for voltage. Would be necessary to generate 10 amps. So that continues down here, but that's a current. So 10 amps. In a circuit that has 5 ohms, that's obviously our resistance here. Of resistance. So this one is the first equation up there. V equals I times R. I is 10. R is 5. 50 volts. We are moving. 1.5 volt battery. Bulb with a resistance of 3 ohms. Calculate current. Current is voltage divided by resistance. So voltage is 1.5. Resistance is 3. 1.5 divided by 3 is 0.5 amps. There's that one. Excuse me. Electric heater works by passing current through 100 amps. There's my current. Through coil metal wire, making it red hot. If the resistance of the wire is 1.1 ohms, what voltage? So resistance is 1.1 ohms. We're looking for voltage. So that's our V equals I times R equation. Thank goodness, because I didn't want to divide those. 100, which is a lot of current, by the way. 100 amps is crazy. Times 1.1. And 100 times 1.1 will be 110 volts. Good. 2 big ones left, and then, oops, some conceptual ones. So let's get those last ones done. What current? Hey. So I'm looking for I. Flows through a hairdryer plugged into a 120 volt circuit. So there's my voltage. If it has a resistance of 25 ohms. I equals V divided by R. 120 divided by 25. And we finally got to one that I don't think I can do in my head. Because 120 doesn't go into 125 or 125. Sorry, 25 doesn't go into 120 nicely. It's like 12 divided by 2.5. 12 doesn't go into 2.5. Or 2.5 doesn't go into 12. 4.8. Had to use the calculator for that one. Current is 4.8 amps. And our last problem here, light bulb has a resistance of 5 ohms. And a maximum current of 10 amps. So there's my current. How much voltage? So we're looking at V equals I times R again. And voltage equals 10 times 5. And V equals 50 volts. There we go. So the last two are just kind of conceptual questions that ask what you think would happen. So what would happen to the current in a circuit if 1.5 volt battery is removed and replaced by a 3 volt battery? So if we increase the voltage from 1.5 volts to 3 volts, what happens to current? Well, if we increase voltage, current increases. Right, that's like turning up the knob on the little voltage box that we use. If we turn it up, the light bulbs got brighter. Right, if we turn it down, the light bulbs got dimmer. That's because current increases when we turn it up and current decreases when we turn it down. So 1.5 to 3, current would increase. And what happens to current if a 10 ohm resistor is replaced by a 20 ohm resistor? More resistance, less current. So our current would decrease. The more current or the more resistance we have, the less current we have. All right, so there is that one. If you have any questions, hold on to them. I'll answer them on Monday, but hopefully you're able to get through that pretty easy. I'll leave that for you. All right, stop that and pause.